M by 2 graphical method. Consider the payoff matrix of the um, of player A and solve it optimally using graphical method. Here if you observe the strategies for player A are 1, 2, 3, 4 and the strategies for player B are 1 and 2. So first we will be considering the row minimum, that is the minimum among 6 and minus 7 is minus 7, the minimum among 1 and 3 is 1 and 3 and 1 is 1, 5 and minus 1 is minus 1, and in these the maximum value is 1 which occurs at two places. And coming to the column minimum, column maximum, here the maximum value is 6 and here the maximum value is 3. Here now we consider the minimum of the maximum, so the value is 3. Here maximin is not equal to minimax, so the problem is not a pure strategy and there is no saddle point for this, For checking the dominance, we have to convert this to a 2 by 2 matrix. So what we did is we are applying the dominance property. For that we are adding the elements of every row, that is 6 minus 7 is minus 1, 1 plus 3 is 4, 3 plus 1 is 4 and 5 minus 1 is 4, and we are adding these elements, and among these first I will be selecting the highest element. I will be selecting the highest total, that is 4. If I observe here, let me take the last row. 5 is less than 6 but minus 1 is greater than minus 7, so there is no dominance. And next I will move to 6. If I move to 6 to the third row, that is 3 is less than 6 but 1 is not less than minus 7. Here also there is no dominance. Let me move to the second row. Here also 1 is less than 6 but 3 is not less than minus 7. Means there is no dominance for all the 4 rows. So here, as dominance is not there, I will solve it by using graphical method. For that I am taking the A's alternatives 1, 2, 3, 4 and B's expected payoff function is obtained by taking the first strategy as y and second strategies as 1 minus y. Means here 6 into y minus 7 into 1 minus y gives 1 value. In the same way, 1 into y plus 3 into 1 minus y gives the second function. When we give the values as y is equal to 0, whatever the strategies we are having will come here, and whatever the strategies we are having will come here, like this. And when we plot these in a graph, the graph as one axis as y is equal to 0 and the other as y is equal to 1, the graphs will be like this. The first point is minus 7 comma 6, first equation, and the second is 3 comma 1, means when y is equal to 0 it is 3 and it is 1. In the same way, for the third equation the values are 1 comma 3, and for the fourth the values are minus 1 comma 4. Now we will take the maximum in all the minimums. Here the minimums of the intersection is these 3 points. In this the value is intersecting at B, means that is the lowest intersecting point. As here there are 3 lines, we need only 2 lines. For getting the 2 lines, we will be considering the most opposite lines. Here one line in opposite direction is 4, the other which is the most opposite is the this equation 2. So we will be considering the values of 2 and 4, and then then we will be solving by algebraic method. For solving the algebraic method, we follow, here I consider A2 and A4 for strategies for player A and 1 and 2 for player B. And for the player A, the strategies are like this. They are A, B, C, D, and here we will be writing the oddments that are written as D minus C, and here it is written as A minus B. Right. In this way, this will be calculated, and this sum will be give the probability as 6 by 6 plus 2. In the same way, when one is known, the other can be known as P1 plus P2 is equal to 1, the other can be obtained. In the same way, for here also, 3 minus half minus 1 is 4, and 5 minus 1 is 4. Or here also, their probabilities Q1 and Q2 are taken as 4 by sum of 4 plus 4 or Q2. And the value of the game is obtained by 1 into 6 plus 5 into 2 by 6 plus 2. That will give the value of the game. Here, as A has 4 strategies, what we do is here only 2 and 4 are been there, the remaining are taken as 0, and their probabilities are taken. And for B, for the two optimal probabilities are 1 by 2 and 1 by 2, and V is equal to 2 is the value of the game.